Hello and welcome again to the Allegro customer webcast. My name is Klaus Degner and I will speak today about the following few items in our webcast today, which is about the new Allegro wiki. It's one of the topics today. And then I've selected 2 new pages in our wiki where I just would like to walk through and explain you how you can optimize the performance settings on the Allegro and how you can do Skype debugging. For Skype debugging, I just recorded a Skype test call a few days ago as preparation. And what I will use right now is I'm using the Allegro and I have set up the Allegro, which is a 3300 in this case, with the parallel PCAP analysis, which allows me to process a PCAP in parallel to live traffic. And what I will do now is I will take just my PCAP here from my test call and analyze it. Now it asks me, okay, you would like to analyze that in your replay slot. And okay, it's done. And now I can see on the dashboard, that was my traffic of the Skype call. Well, the very simple thing is, well, let me show you that what I'm talking about in the wiki right now, which is debugging Skype traffic. The very important information is that Skype is an encrypted protocol, which makes it very hard to do analytics on the content, but the Allegro delivers you a lot more quality parameters, which are not based on the content, but on the layers below. For example, TCP, or for example, already IP information. Where do my connections go? So once we go to the IP statistics, for example, we can immediately see that for this PCAP, I had my local address, of course. And here we see that was my setup when I logged into Skype. And part number 2 was my Skype call. The interesting thing, what I can see immediately is that the voice went to a server on that IP address. This belongs to a Microsoft autonomous system, so it's an IP address of Microsoft. And the location could be true, but it's an indication. And here you can see, oh, where does the RTP connection go in this case? Also, just imagine you're on a big link. What you can, of course, do is you can search in real time for Skype. And then you see all IP addresses that have been used and where they are located. This allows you very easily to see which IP addresses had most traffic. And again, if we look, for example, now to that IP address, we can see who connected to it. And it was, of course, my local IP address. Here again, of course, we can use the PCAP button and look back in time, for example, with the preview. And oh, I know I did a mistake when I started the PCAP. I did not, no, I have to do the opposite. I have to mark the time frame. Now it's working. And here we see the encrypted traffic and the login. Well, Skype is a protocol which is based on as of today, on the Microsoft Cloud. So you see a lot of requests not only going to Skype, but also to other Microsoft servers. So performance statistics can be done easily if you look, for example, if you go, for example, to the TCP statistics. And here we can see in that time frame what was the server handshake times, which is quite simple. So my Allegro is very close to me, and I can say, oh, there have been handshakes which took more than 200 milliseconds. Maybe that's a server in the US, for example. And now, of course, you can see sorted by, let's take the average round-trip time, that, oh, there was a server in Japan, for example, where our database tells us it's very likely that's in Japan. Please note that Microsoft can move these IP addresses around the world as they like. and our internal database, we try to keep it up to date, but it's not very easy to have it on daily basis updated. So here you can easily see where are long round trip times. Giving you a simple example, we had a German customer where they complained about very, very laggy Skype connections. And the reason was, why ever they don't got to the European Skype cloud connected, they got to the Asia Skype cloud. So all connections went to Asia and back. And of course, that makes the service quite slow. Also, where you can see a lot of details is, of course, TCP response time. So how long did the TCP stack need to acknowledge received packets? And for example, here we see on the promotions.skype.com, it was about 100 milliseconds. Others were faster. And longer round trip times always are a good indication that there's an overload somewhere in the path, which causes buffers to be filled and longer round trip times. Again, TCP retransmissions are also a very good value. Oh yes, I'm working on a development preview right now for a few features I will show you later, where we have a bug which shows us negative values. But in this case, we see one negative value. The rest are all 0. So I had a quite good connection to the Skype service. This is about the control traffic, where we see a lot of values. You can do the same for the SSL traffic, for example, and see there a lot more patterns. A good way what we also expanded is that you can see in the IP statistics right now, you can select the graph and then say, oh, please don't show me the traffic in bits per second, but for example, show me the TCP response time. And here you get a good overview of the response time of these servers on one page. Okay, now part 2, which is the not the Skype control traffic, but the more important part is the Skype VoIP traffic. Skype uses encrypted RTP, which is very easy to debug because we see for encrypted RTP, we see the RTP header, which gives us a lot of information for example, for jitter, for packet loss, and we can calculate a lot of these values here. So the content itself, it's Skype proprietary, so we can't do any analytics on it, but we can show you for the layer 7 application, the RTP statistics. And here you see that we had 2 RTP connections, and because it was a Skype test call, and you see the received and sent bits per direction. You see the lost packets, which was 0, so very good in my case, and you see the jitter for both directions. And the interesting thing here is jitter and drop packets are the 2 very important values to measure VoIP. If the jitter is too high, it means that the arrival time of the packet is not constant. Most codecs use constant sending rates, and a high jitter means, okay, somewhere in between there are buffers which are full or empty, or for example, if a Wi-Fi is in between, the Wi-Fi could be overloaded by bursts. And so in our case, I see an RX jitter. So this IP address has received traffic with a jitter of 3 milliseconds, which is quite good. If you look to the internet, that the traffic coming back from the internet has only 3 milliseconds jitter. On the opposite side, the traffic that has been sent, we see here is very, very low, the TX jitter. So it's below, well, it's 100 microseconds, something like that. So that's very low. And that helps a lot to look into the traffic. And of course, you can always do the post-processing with WebShark. And then, well, you have the raw data and can look into that a lot more in detail. Okay, so this case, of course, you can read a lot about that in the new wiki page, and where we also added information. If you go deeper per IP address, And so this statistic is available easily. Okay.